Alrighty then, we've got 2 exciting days in a row for space weather. We've got a solar energetic particle event, radio blackouts, radio bursts, and all kinds of other stuff going on. We've got a coronal mass ejection about to arrive at Earth. We'll tell you all about it and more here at the Smash News Network, least busted name in news. This is the past 24 hours in ionized helium from the Solar Dynamics Observatory, and you might see some action happening over there on the right side. What's that? You want a closer view? All right, well, I guess the most comprehensive daily space weather content in the world and the most detailed solar imagery you'll find any place ought to have such things. So there you go. So there was an M-class flare. It was of long duration. It generated a solar energetic particle event where solar protons traveling at a significant percentage of the speed of light find themselves at Earth rapidly, only about an hour from the onset of that solar flare. Here we're going to add 193 angstroms to show a little bit of extra depth to the filamentary portion of the closest star. That's ionized iron from the Solar Dynamics Observatory. And the story has been, for the last week, filaments. So zooming out, you can see a lot of dark, snake-like ropey features all over the Earth-facing portion of the solar disk there. A lot of those dark features there are not coronal holes, but are indeed plasma filaments. So you can see one hanging out there around the northern polar region. That is a crown prominence, right around the Earth scale there, sort of encircling the north solar polar region. Here's a close-up of the equatorial region. Here above the Earth scale, you'll see another very large plasma filament. And there are indeed plenty in the southern hemisphere as well. So there you can see a crown prominence also hanging out at the south polar region, prominences around the southeastern limb. And again, that is and has been the story for the past solid week or so. Here's yesterday plus today from the SDO continuum. And it looks like a little bit of degradation and a little bit of umbral migration happening in this sunspot group. A little bit of evolution of this sunspot happening as well as it approaches the limb. It will remain the most likely place to see a large solar flare. And here is colorized magnetogram. That is also yesterday plus today, August 31st, the whole day, and then September 1st to date. So that's a brief synopsis of what's going on. Don't worry, we're going to show you all the stats. Here is the scenario for erupting volcanoes. So we'll start out the list with Shivaluch. Shivaluch here, NA, not applicable. It's on the list, but it's not applicable. I don't know. I don't make the list. Mount Mayan has produced a volcanic ash cloud of unknown size. Please don't pole vault the caldera. Mount Ibu exploding, and that's actually what this image up here is. That's Mount Ibu there. And it's produced an over 9,000-foot ash plume there over Halmahera, Indonesia. Luatolo exploding flight level 060. It's a 6,000-foot ash plume. 15,000-foot ash plume over Semeru. That's located on East Java, Indonesia. Now down to South America, we've got Revenador exploding, flight level 150, and Sabancaya exploding in South America. Flight level 220, it's a 22,000-foot plume of volcanic ash. Next, seismic update. Earthquake activity has been moderate over the past 24 hours. We will cite quakes of a 5 or greater magnitude. Starting out the list is a 5.4 at Indonesia. That was at 10:29 Universal Time, and that's been the most seismically active region on the planet there, that area north of Australia, for the past about 48 hours. Again, we'll cite quakes of a 5 or greater magnitude. There's a 5.0 at Tonga. That one was a depth of 164 kilometers. It was at 19:18 Universal Time yesterday evening. And then only about 15 minutes later, a 5.3 at the Solomon Islands there. West of that location at Tonga, that 5.3 at 19:33 Universal Time. Also some shaking going on at Hawaii. Nothing over a 5 magnitude, likely magmatic motions there underneath the Kilauea or perhaps Mauna Loa complex. We won't worry about that because it's time to get back to space. And it's an exciting time for space weather. There's a coronal mass ejection, which is likely to strike exactly when forecast yesterday on September 3rd, on Sunday, early in the day on Sunday. We were saying midday, but hey, maybe it'll be moving a little bit faster than we expected. So here are the past 24 hours from STO 171 angstroms. Here's a little closer view. This is another one of the species of ionized iron. And let's talk stats. So it's a great example of how you can see a major uptick in solar activity without really seeing a major uptick in things like the radio flux. So we did have some radio bursts. However, the 10.7 only came up one solar flux unit since yesterday. So the radio flux now at 140 solar flux units. There's the one-year graph of the 10.7 centimeter radio flux depicted by this black line. The red line is the sunspot number. Those are the two most important features of a solar cycle to determine how close we are from solar maximum, solar minimum, etc. Next, the NOAA forecast for the CME impact we're expecting to arrive on Sunday. I expected peak flux to be around midday, and that is pretty consistent with NOAA's forecast there. It is pretty much a perfectly oriented, directly at Earth type coronal mass ejection. So yeah, that's NOAA's forecast. It is pretty diffuse, exactly as we said on yesterday's video. And there is the forecast. NOAA expecting a possible G1 class geomagnetic storm, a KP5, expected early in the day by NOAA on Sunday. I think it's a little bit slower than that. I think peak flux will be more like around midday, but hey, we'll cover it tomorrow. We'll cover it every day, but Sunday morning we'll cover it as well, and we'll see what's going on. So that's NOAA's forecast. Here's NASA's forecast. This is NASA's Enlil spiral. And it's a pretty similar impact time there forecasted by NASA. So those are the facts about the CME impacts, and guess what? There's another one that was launched. We'll get to it here in a minute. First, the last 4 hours of Earth's magnetic moment from space. This depicts magnetohydrodynamic pressure around planet Earth. Magnetohydrodynamic pressure in the units of nanopascal. Those are the units of magnetohydrodynamic pressure. Again, that's the last 4 hours of Earth's magnetic moment from space. And we'll let that play all the way through there to get the most updated data onto your screens. So that's what's going on. And next we'll show Earth's magnetic moment from the ground. Here the units are nanotesla, magnetic flux density. We have seen a little bit of an uptick here in the solar wind as well, although it's not super fast and it's not super dense. So some aurora likely visible here, both in the southern polar regions and the northern polar regions especially. The last 4 hours of Earth's magnetic moment from the ground. Next, our KP index, otherwise known as the planetary K index, an average of global geomagnetism currently at 2.67. So we are expecting the possibility of this coming all the way up to 7 on Sunday, but I would say probably more like 6. It all does depend on magnetic field organization, how dense the CME is, and the speed of it. Of course, it also does depend on magnetic field intensity. So let's look at the real-time solar wind now. And here's the current situation. We're at a nominal solar wind speed here just above 400 at 410 kilometers per second. So that's pretty average. A little uptick in the solar wind density here since yesterday, currently at 7.5 protons per cubic centimeter. Next are GOES magnetometers. These are geosynchronous near equatorial satellites. And yeah, a little bit of some minor spikes there as Earth's system attempts to reach static equilibrium. No big deal. It's right around midnight local time for the GOES 18 here at the moment. That's what that blue M represents. That's midnight local time for the GOES 18. So just a little bit of an increase there. Of course, as we showed in the Geospace Magnetosphere movie, most of the plasma density is on the nighttime side of the planet, so consistent with the data there. Next, our top view ecliptic plane field plot. And that is depicting the heliospheric current sheet and its polarity. So what we're seeing here is an extension of the North Pole current sheet. We can expect that to remain there for days, assuming we don't see any strong sunspots in the northern hemisphere, especially the northeast. So here at the moment, Earth is right in the middle of a large North Pole current sheet. There it is depicted in green. South Pole current sheet is several days out there, probably something like a week plus, until we see another sector boundary crossing. Here's our line of sight field plot. This depicts the solar B field, which is kind of like a net field of the north and south polar fields, which are depicted in green and red respectively. It also shows the grayscale gong magnetogram there for the photosphere level. The red, blue, and green lines depict coronal magnetic field lines, and the grayscale depicts the photosphere's magnetic fields. That's where we see sunspots at the photosphere level. Next, our line of sight coronal hole plot. And we've got North Pole coronal holes all over the Earth-facing portion of the solar disk, which is what you would expect while inside of a North Pole current sheet. So there's the latest image. And let's take a look at it from SDO. So here's the SDO 211 angstroms wavelength, another species of ionized iron. You can see that event happening on the northwestern limb, exactly where you would have expected to see it if you would have watched yesterday's daily space weather content. So that's what's going on. These are all North Pole-oriented coronal holes. So, and you can expect a continued increase in coronal holes as we've seen a shortage throughout the cycle, and that will not continue. We're still like a year out from solar maximum, so you can expect the most transequatorial coronal holes around solar maximum. That's just the way it works, folks. These are magnetically driven processes. Next, we'll move to sunspots. Sunspots, anybody? Sunspots? Okay, here are sunspots. And no major changes. Again, we saw some umbral migration from sunspot 3417 and a little bit of evolution from sunspot 3413. That remains the most likely place to see a large solar flare. There is still some possibility of a large solar flare from 3415, but again, 3413 is the most likely spot to see a large flare. Next, a 24-hour video featuring 94 angstroms as well as the SDO continuum. And we showed 94 here so you can see that long duration M-class flare. Very obvious there up in the upper right corner, the northwestern limb of the closest star. And let's subtract the 94 angstroms here just to show any sunspot evolution. Yeah, again, you'll see some umbral migration over there on the left and a little bit of sunspot evolution up there in the upper right. Besides that, those spots are largely stable. Oh, one small pore did open down here. So one tiny sunspot has also appeared. And then degraded. Here's the SDO magnetogram also. These are 24-hour videos, by the way. Time and date stamps are shown down there in the lower left. Which brings us to solar energetic particles. Again, we just had a solar energetic particle event. So let's take a look at that. And there is that SEP. So those solar energetic particles only took about an hour to get here. So, and they have caused some polar radio blackouts, as you would expect. They are above the 10 mega electron volt warning threshold. So that's the GOES proton flux. And here is the blackout situation. So that was, again, that was a long duration M-class solar flare. Here's where it occurred. Peak flux was around, clearly around 4 o'clock this morning. And then you'll see those solar energetic particle events arrive there at the poles. So that's a solar flare attenuating the D layer of the ionosphere, and these are those relativistic particles attenuating the polar regions there. So you can expect those radio blackouts to continue for a couple of days here. They look like they have leveled off, though, so it's not a major SEP, just a little bit into warning levels. And of course, that will affect high-frequency radio communications around the polar regions, especially the North Polar region. It is summertime, after all. That end of the planet is slightly more tilted toward the sun than the south. So here's that long-duration solar flare, and peak flux was sometime around 3:48 Universal Time, and it was a very long-duration flare. And I mean, here's one of the big spikes. So it looks like it only took about an hour for those solar energetic particles to arrive, which means they were traveling about 23,250 miles per second, a speed of about 12.5% of the speed of light. So that's why we call them relativistic particles. They're traveling at a significant percentage of light speed, or c. You know, like E equals mc squared. Anyway, let's take a look at those flares in a little greater detail. So here are the past 24 hours in 94 angstroms all by itself, one of our best wavelengths through which to view flares, and there's that long duration M-class flare. And we'll let it play through one more time. I think it's well worth it. Here's another of the two top wavelengths through which to view solar flare activity, 131 angstroms. This is, by the way, the hottest frequency covered by the SDO AIA instrument. How you like them apples? Pretty sweet, right? Next, we're going to move on to take a look at a star chart. So we may have a lot of people looking at the sky. First thing in the morning on Sunday, perhaps. When you wake up, you may be able to see some aurora, even at mid-latitudes, perhaps. It's distinctly possible. Here's a star chart of what's going on over Lehigh Valley, Pennsylvania, where Smash Staff and I are located, from skyandtelescope.org. You've got Jupiter. You've got a large, bright moon up there. Also the third brightest object visible in the morning sky, Venus. Next, the solar system forecast. But first, take a moment to press like and subscribe if you enjoy the content. The world's most comprehensive daily space weather videos, as well as the most detailed imagery of the sun. Press the like button. No, that's okay. We'll wait. Have you pressed like yet? If you don't press like, we will find you and we will shame you. Thanks to our new subscribers, in all seriousness, we will not be celebrating 4,000 subscribers. However, when we get to 5, maybe we'll create a video about that. Thanks again to everybody who supports the channel. These videos are brought to you in part by the Smash team. More on that later in the video. First, a solar system forecast. So this is where things are today. And here's where things will be in a week, on September 8th. That's what's up. And before we get to our coronal mass ejection imagery, how about the astronomy picture of the day? Globular clusters are kind of like small spherical galaxies inside of a galaxy. Now this one features a series of different types of stars. As you can see, red and blue stars in there. They are all orbiting a central point of gravity. So they're all orbiting their common gravitational barycenter, as it's called. Again, you've got red and blue stars in there. Not all globular clusters are like that. Some of them are more homogeneous than other ones. This one is located about 26,000 light years from planet Earth. So, of course, it is in the Milky Way galaxy. It's about the same distance from Earth as the galactic core is, just to give you some indication of that. The Milky Way galaxy is about 100,000 light years in diameter. This globular cluster is about 100 light years in diameter. And I have no idea what the name of this one is. We'll tell you that in a minute. I don't memorize things that I can look up. Here's the full view of that globular cluster. It is known as M13 from the Messier catalog. So Messier was looking at blurry objects, many of which were actually galaxies, thinking that they were some sort of nebulae. M13 there, the globular cluster in the constellation Hercules. Next, CMEs. And guess what? There's another one that may have an earthly directed component. Now this one's not directly headed toward Earth. However, it does appear to have a small portion of it that may strike Earth. So just because the solar energetic particle event occurred does not mean it will hit Earth. And this was early this morning, along with that M-class flare event. That's 101 frames from yesterday, August 31st. Here are the frames from today, and that's generated a massive CME. It is quite spectacular. It does have a very dense core, but the dense core is not headed toward Earth. So anyway, here is the view from Soho Lasco C2 and C3. And we're going to show a little more detailed view of that here in a minute. There you can see that quite significant CME, and you can see part of that is sort of showing up on the left side of the coronagraph there. That would be the east. And because of that, we do anticipate that this may have an earthly directed component as well. Now this one's moving quite a bit faster. We expect this one to arrive later in the day on the 3rd. So this one, this is going to be part of a 1-2 punch here. So a second CME impact there expected later in the day on the 3rd. So Sunday night, expecting a second impact. So here we've paused our coronagraphs at 0 dark 100, 0, 0 dark everything. We're going to just let those play through here. So there you go. 2 more CMEs. 2 CMEs are headed this way. One was generated just this morning around 4 o'clock Universal Time. So we'll let those play all the way through there. There's the full data set from yesterday and what we have from today. And we'll also show stereo A, as it includes some quite spectacular imagery as well. So we just show this diagram to show the location of stereo A here. It's just moving to Earth's west. It's almost in line with planet Earth, so it's not providing great trajectory information. But here we've paused it at 438. So that's what's going on. And let's bring these back and let those play through as well before we show you our custom coronagraphs. So this is around midday yesterday. And then there's that berserk CME this morning. How you like them apples? Pretty sweet, right? Next, here's our custom 24-hour coronagraph, complete with the SDO 193 angstroms. You can actually see the solar energetic particle event there striking the Soho Lasco spacecraft, located at Lagrange 1. That's about 1 million miles from Earth. And you see like a bunch of snow on the imagery there. That's only about an hour after one of the spikes in that solar flare. Relativistic particles there traveling at about 12% the speed of light. So we've got some closer views here as well. We'll zoom in one step. It's exciting solar stuff going on at the moment. A great example of how you don't have to see that many sunspots or even major flares to see major events. Speaking of major events, let's talk about filaments. Yeah, filaments. They're pretty serious, and like we said, the past couple of days, filaments are littering the Earth-facing portion of the solar disk. So here's the El Teide Spain ground-based hydrogen alpha telescope, and indeed, look at all the filaments. The most noteworthy of them is this one down here in the southeast. It's very dense. It's very long. You can also see that southern polar crown prominence. Let's switch to the grayscale view so you can see the prominence is a little bit better. Filaments, filaments, filaments. They continue to litter the Earth-facing portion of the solar disk. Many of those could become additional coronal mass ejections. If you want to name filaments after living people, well, join us over on Twitter. Just follow the hashtag #NameThatFilament. Of course, Twitter is a zombie corporation that can't get out of its own way. It's like a zombie at the wheel of a self-crashing car. As we are shadow banned over there, you'll have to actually go and create an account or press the follow button. I don't know. We've had the account since 2019 and over 21,000 tweets. And we've got 455 followers. Why? Because nobody sees the content. That's why. It's called censorship. If you think Elon has fixed free speech on the internet, zombie corporations are not fixed. Zombie corporations are corporations operating on their own inertia and barely functioning as they mislead users, investors, advertisers, etc. Twitter.com/smashamash. Use the hashtag #NameThatFilament to name solar filaments after living people, like your friends, your foes, and even yourself. Check it out. Here's the level of shadow ban that goes on Twitter. Now, we do have a Facebook account as well. Facebook.com/smashamash, as you may have guessed. And check this out. I'm just going to show you how deboosted the tweets are. So what we have here is dozens and dozens and dozens and dozens of tweets. You see this right here? That's showing zero engagement. Zero engagement. So this is over 20 pages of tweets that all showed up in the same place on my timeline, and almost none of them had any engagement. There's probably like about 100 views of dozens and dozens and dozens and dozens and dozens and dozens of tweets. So if you think shadow bans are fake, if you think censorship is somehow fixed on the internet, you are deranged and delusional. You have to actually do stuff like subscribe to the channel, subscribe to email notifications, because there is a massive bias by these zombie corporations. So I'll just stop ranting there and show the last 2.5 hours from the GO 16 SUVI. That's 304 angstroms ionized helium. And what's great about this view is that it does show the extended corona there. So it's very good at showing coronal mass ejections. And of course, we streamed last night's events. You would be able to find them on the Twitch channel. And here is how that absolutely berserk CME looked from the GO 16. Anyway, that brings us to our bonus feature segment of the space weather portion of the video. Here are satellite charging hazards, and we do have some minor surface charging hazards there as low-energy electrons are building up on the outside of spacecraft in the East Pacific and around Mexico. Those shouldn't cause any major communications breakdowns, just minor ones. Here's the GOES electron flux over the past 3 days. And we are seeing low levels, which is, I believe, what NOAA forecast. Here's the one-year chart. Yep, a little bit lower than they were yesterday. So that's the one-year graph of the greater than 2 mega electron volt electron fluence. And here is the forecast model. Not quite as low as NOAA forecasted. The next update should be a little bit lower than where you see that latest yellow diamond, which is the observation. We'll show the layer of the ionosphere where that's measured, the F layer, located at 300 kilometers of altitude. Here's the vibrational frequency of that layer, the bridge between Earth and space. So this is 2 layers above the layer where we showed the deabsorption region. This is much more diffuse than the D layer. And it's actually hotter as it is closer to the sun. So that is what's going on in vibrational frequency. At about 300 kilometers of altitude, the vibrational frequency depicted here is megahertz, millions of vibrations per second. Here's the anomaly gram. That's anomaly in megahertz from a 30-day median. And we're expecting to see a lot of red in this, at least by Monday's daily space weather video, as there's quite a bit of activity expected on Sunday. So it's going to be a big Sunday for space weather. Here's a latest image. That's 10:15 universal time for the ionogram and 10:15 universal time for the anomalygram. We also show total electron content on the channel daily. This will show you the most likely places for GPS errors. Your GPS satellite has to communicate through free electrons from about 12,500 miles down to your handset. And there is the CTIPE, the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. If you're expecting GPS errors, try using Wi-Fi location accuracy, as the fixed IP addresses may help you navigate if there are Wi-Fi hotspots around where you are navigating. We also show the total electron content over North America. This is the anomaly in megahertz from the 10-day average. And there are some minor anomalies here over Central America, Mexico. Here you'll see those popping up at the end. Right in there, some high electron counts. Central America, southern Mexico mainly. The last section of the space weather video is always our latest intensitygram and latest colorized magnetogram. Again, this is the most likely sunspot to see large flares. It is beta gamma delta class. However, its proximity to the limb also makes it more likely to produce large flares. This group down here a little bit less complex. Well, pretty similar. It is beta gamma delta class, barely. Anyway, here's your full disk rock back. It's time to do meteorology. And what should we start out with on the meteorology segment, folks? What do you think we should do? How about sea surface temperature anomaly? So we're going to show the sea surface temperatures and the surface winds of the planet first. There is your sea surface temperature anomaly. And for everybody who's claiming the Beaufort Gyre is going to empty out and push a lot of cold water into Europe, well, where is it? If there's all this cold water coming out of the Beaufort Gyre, why is the water so warm in the North Atlantic? It's just not a thing. And people who don't understand physics should not be forecasting your weather, especially in space, but also on Earth, because they have no idea what they're talking about. If you don't understand physics, you can't forecast your next bowel movement. All right, so there's the Arctic Ocean, which is, there is some cold water around the edges there. However, it's certainly not doing stuff like disrupting the Gulf Stream and the AMOC. That's just ridiculous. Ridiculous and not occurring. So more idiotic forecasting by idiotic channels on YouTube. So there's the Atlantic Ocean, and you can see the North Atlantic is almost entirely high temperature anomalies. There is a strong low there south of Greenland also. Here's the Indian Ocean. We'll go east. There's the Indian Ocean's temperature anomaly and sea surface temperature anomaly and surface winds. Here's the Southern Ocean, which is a mix of anomalously warm and anomalously cool water. And last but not least, the world's largest surface heat sink, the Pacific Ocean. There's a lot of water in there. And check out the equatorial high temperature anomalies. Also the North Pacific high temperature anomalies. Some channels will show you this. They'll do this. They'll say, oh, noes, look at how cold the water is in the Pacific, folks. Oh, noes, Hawaii is going to be encased in ice. Pardon my sarcasm. All right, so here are the standard features of the meteorology segment. Surface winds of the eastern world. Jet streams of the east. Jet streams of the central world. Surface winds of the central world. Let's don't forget surface winds of the west. Shout out to our viewers from all around the planet. And the jet streams of this side of Earth. So that's what's going on. Next, our satellite imagery. Some fantastic satellite imagery there from windy.com. And they're getting inundated in Arizona, Utah, and about to be in Nevada. You see some heavy cloud cover there. There's some heavy rain there. We'll cover a forecast here in a moment. First, clouds and fog from the NASA GOES interactive weather satellite. It doesn't need to be daytime to see clouds and fog. You can use shortwave radiation. Why? Because clouds emit infrared radiation, folks. That's why it stays warmer on a cloudy night and cooler on a clear night. That's why deserts get so cold at night and so hot in the day, because of a lack of clouds. They block the sun in the day, and they reflect infrared radiation from the ground level at night. Anyway, or you could say they re-emit infrared radiation. Anyway, here is our weather.gov map, and you can see a bunch of flooding there for Nevada, Southern California, Utah, and Arizona. I'll scroll down to show you the key. However, your best bet is to just head to weather.gov. If you can see this video, you're probably capable of viewing a website. Maybe not. Maybe you can only use apps. I don't know. Anyway, here comes some forecasts. This is the GFS total accumulated precipitation forecast, and expecting, again, some heavy rains there, especially in southern Nevada and northwestern Arizona. Also, Utah's got some flood warnings, but the heaviest rains, again, southern Nevada and northwestern Arizona. Expecting like 5+ inches of rain, 5 or 6 inches of rain in some of those areas. That is pretty significant. Please be prepared. Please be prepared while certain channels that, quote, cover and, quote, space weather attempt to make you scared and sell you bunker supplies. Pretty pathetic, I know. Here's our pressure and precipitation forecast. This is the same model as the last one, the GFS 72-hour pressure and precipitation forecast. So heavy rains will persist here and accumulate quite a lot in some very specific areas. Okay, next. The jet stream forecast. It is the same model, the 72-hour GFS jet stream forecast. As we bring you unbiased information and facts, which are very controversial, as it is the year 2023 after all. And here is our lightning mapper. And these weird flashes that you're seeing up here, these are the surface charging hazards that we talked about earlier. There are some low-energy electrons showing up on the lightning mapper, because when you see lightning on the outside of the aperture, it shows up as errors on the lightning mapper. Those aren't directed energy weapons, alien spacecraft, or anything spooky. Those are from electrons building up on the spacecraft. Let's take a look at a real-time lightning map from lightningmaps.org. Do we have terrestrial strikes? Looks like we do have some minor lightning here around the area that we mentioned, around Mesquite. Next time you hear thunder, check it out, lightningmaps.org. It could save your bacon. And by the way, we're saving the bacon as well by putting out facts. Yeah, facts.